Hello, in this video I'm going to speak about the concrete columns. And as you can see in this picture here, we have a heritage building and the timber was used as a supporting column for this building. Now, few meters away from the same building downtown Toronto, you have a high-rise building and with this entrance. And in this entrance, you can see there are some columns, inclined columns here as architecture feature in the building. Now, we can argue about these columns. Are they load-bearing columns or just as a decoration inside the building? If these columns are load-bearing columns, now the architect has to consider that within the ceilings there should be a tie or another member which will support the columns in the horizontal direction, because there is a, a component of this column force to be in the horizontal direction. And also we have to consider that the load bearing capacity of this column will be much less than a regular concrete column. So a regular concrete column as shown in this picture, which is one of our project in St. Catherine in my office. And here we have an existing building with the basement as a parking garage. In this parking garage, you can see the different types of columns, and the spacing between the columns should be chosen that it can provide enough space for the parking. And that will be our topic for this presentation, is the concrete column, reinforced concrete columns. Now I divided the topic to be in different sections. One section will be the introduction, definition, and materials, and another section will be the behavior and design of the column, and the last section will be about construction and inspection of the concrete column, reinforced concrete columns. Now, if you look at this column here, the column is the item or the member which provide us with the space to work on. So the column is supporting a floor or a roof, and that can provide us with the space to use in. And normally the loads on the columns here are compressive force or compression, unless the building is supporting or subjected to a normal lateral load that can come from the seismic and the lateral the wind load. And if there is no shear walls within the building, then they can have a frame action, and these columns can see some bending moment, and the loads will be not only compression force. Now, the definition of the column in the Canadian Code and Canadian Standard Association, so it defines a column as a member which has a height ratio of the height to the least cross-sectional dimension more than 3. So if you look at the least cross-sectional dimension is this part, and that's the height. If you divide the height over the width, if it's more than 3, then you are talking about column. If this ratio is less than 3, so that means, for example, if the column is that height, only that high, then you can talk about pedestal. And that's for the height and cross-section definition. However, the cross-sectional area of the column has also some requirement. So in the Canadian Code also, the columns can be considered as a column if the ratio of the long direction to the short direction is less than 6. So if that the ratio is less than 6, then we are talking about column. If the ratio is 6 or more, then we are talking about concrete wall. Now the dimensions here, what are the minimum dimensions for the column? So we can say that the code requirement sets the minimum dimension to be 200 millimeter, and if that's the cross section is rectangular section like that, so the minimum dimension will be 200 millimeter. Now if the cross section is a circular like in this picture, then the diameter of the cross section should be 300 millimeter or more. If we are providing a fire resistance for the building and what we call it fire rating, if we need 1 hour fire rating, so we can have the dimension of 220 millimeter as minimum. If you need 2 or 3 hours fire rating, then you can have the minimum dimensions of 300 millimeter. Now I prefer not to go below 250 millimeter if you have even 1 hour fire rating. Now, when you look at this concrete column, can you expect reinforced concrete inside or only concrete? So when we have this beam is supported on the two columns, it can provide its reaction to this column, and another beam here provides the reaction to this column. So based on the distance or the span of the column of the beams and the amount of force it can bring to the column, you can expect some eccentricity in the column, which means that the load will not apply at the cross section of the column. So we call that eccentricity. Now during the construction for the formwork, also the column might not be 90-degree exactly on the site. And we know that there is construction tolerance in the construction industry. So if you have imperfection on the site or eccentricity, so the code provides us with a minimum reinforcement and to be inside the column regardless from the capacity of the column. So we have to provide minimum reinforcement for the column to uh, account for eccentricity or imperfection. What are these amount of the area of steel or the minimum reinforcing bars? That will be explained in the next slide. However, we know now that reinforcing steel bars are required regardless from the amount of load applying on our structure. As agreed, we need to have reinforcing concrete bars inside our concrete columns. What are the amount of the area of reinforcing concrete bars? So we can talk about the ratio right now. And when you calculate the cross-sectional area of the column, and we have to provide a minimum reinforcing bars in the vertical, that they are the red ones. This area will be at least 1% of the cross-sectional area of the whole column. So if you have like 5,000 millimeter square cross-sectional area, then 5,000 times 1%, then you can choose the total area of your reinforcing concrete bars. Now, the number of bars should be in rectangular or square columns at least 4, one in each corner. The maximum reinforcing bars or area of reinforcing bars is limited by 8%. So we can't put too many steel bars within the concrete column more than 8%. Why that? Because we need to have a compaction and we need to get the concrete through the whole cross section, and we need to limit the total cross sectional area of the steel. So the upper limit is 8% and the lower limit is 1%. And in case that we have a rectangular or square column, we need to have at least 4 bars. Now if we have a circular column like this, so the minimum number of bars will be 6. And here you can see that we have the rectangular columns with the bars are tied together by the ties, which is the blue member here, and they are ties along the whole height of the building of the column. And is a circular column, the same thing. We have also ties, the blue ones, through the whole height of the circular column. However, if we are talking about spiral column, we will have the tie but as one piece, as one steel bar going along the perimeter of the steels, so as one piece, and we call it spiral column. And this spiral column has a specific requirement, and it's also increase the capacity of the column, and you can expect that will be a little bit expensive than a regular circular column. Now, to provide the reinforcing bars within the reinforced concrete columns, we need to have a concrete cover around it. The concrete cover has the item or the job of protecting the steel bars from the environmental effect, and also it can protect it from the fire. So for the environmental effect, if your column is exposed in the air, and then you can have a concrete cover of 40 millimeter. If your column is within a building and it's in controlled environment, then you can go with 30 millimeter concrete cover. That's only for the environmental effect. However, the requirement for the fire, if you need to have fire 1 hour fire rating, which means 1 hour fire resistance, so you need to provide at least 25 millimeter. Or if you need to have 2 or 3 hours fire resistance, then you have to provide 50 millimeter as concrete cover for your steel bars. Now, as you can see, we have here the vertical steel bars and we have the horizontal steel bars, which we showed in the other picture as blue ones. Now, what is the job of the horizontal reinforcement and what are the requirements for the horizontal reinforcement? You know that the horizontal reinforcement, they will first of all, they will connect the reinforcing bars. You can't have the reinforcing bars in place without getting them support. So they can hold the reinforcing bars in place, and also they provide the support for the steel bars from the buckling. So if you are applying normal force on the steel bar like that, it will buckle, and you need to have a lateral support for the steel bars. And during my PhD research, I worked on the confined concrete columns, and that was one of my research topic. So this here, when you have when you design the reinforce the horizontal bars to resist force, then that can increase the total capacity of the column. Is like confined columns. And if you can see in this picture, that's not part of my PhD. That's one I have that from the textbook. And here you can have the concrete column. It's collapsed after the collapse of the concrete cover, and also the very important one is the collapse of the horizontal reinforcement. So when the horizontal reinforcement cannot support the longitudinal bars against buckling, you have a crack, or you have crack in the cross section, and then the ties failed, and so the tie fails, and then the reinforcing bars didn't find any support for the bars against the buckling, so it starts to buckle, and at the end you have a complete failure for the column. That's very risky and very dangerous situations. Now, what is the minimum size of the ties? So the code says is minimum number 10, or it can be 30% of the diameter of the longitudinal bars. So if you have a longitudinal bars of 25 millimeter, then 30% of that. So you can use the size to be as a horizontal reinforcement. So normally in my office, and my recommendation on most of the Canadian common practice, we use number 10 as a horizontal reinforcement. Now, what is the spacing between them? I know now the size will be number 10, but I want to know what is the spacing between them, how far they are away from each other. Now the code specifies that the spacing between them shouldn't increase than 16 times the bar diameter. So you have this bar. If you have a bar number 20, for example, and you have 16 times the bar diameter, that means 320. And you have also the 48, the tie diameter. If you are using number 10 as a tie, 48 is 480. So you have 480, and here you have 320, and the least dimension of the column. If your column dimensions here is 250 and the other one is 500, so the least dimension will be 250. That means the maximum spacing between the stirrups or the ties to be 250. So you have 250, and here 480, and here will be 320. So you use 250. So the spacing in this case will be number 10 at 250 millimeter on center. Now, how we can choose the concrete column size? Now, first thing is we have to look at the architectural drawing to establish the the shape and the location of that. So the shape itself, it can be rectangular, or it can be square, or it can be circular. Second thing is we have to use the minimum, to start with the minimum dimensions of the code. And as I said, preferred is 250 millimeter or 300 millimeter for circular column. And then we need to check the total height of the floor, and we want to make sure that the column will be a short column. Now at this point we have to differentiate between a short column and slender column, and that will be something to discuss in completely different video. But here we will assume that we are talking about a short column which will not have impact of the moment or eccentricity on it. So number 4, what about the spacing between the columns? How I can choose my spacing? As I mentioned before, it's very important to keep the architectural layout intact and functioning. And then you can look at also uh, spacing. If you have the choice, you can say my spacing for the concrete columns are in residential or small building from 4 to 6 meters. If you have commercial or office building, it is common here in Canada to use up to 9 meters spacing. If you have institutional building or a special building like banquet hall or something, so or lecture hall, then you can use a different concept, and then you can go with a frame. So that will be a special item. You have to look at the framing, at the architectural drawing, and choose the location of the columns to make sure that the architectural function is maintained. As you see that we spoke about the an introduction, definition, and the material, and in the next section we will speak about the behavior, design, and also we have the construction and inspection.